Okay, so I'm going to continue on from the previous video, which was how to calculate gable and hip roof bevels. These are all the calculations that we did previously. We converted pitch ratio to rise per metre run, and so on down to the final bevel, which was the backing angle. We've got all these answers in place, and we will be referring to some of them for the next calculations when we need to determine the length of certain roof members. So we're going to need the true length of common rafter per metre run, which is this calculation here, and the answer for that was 1.155 metres. So we'll be using that calculation for true length of common rafter per metre run in our following calculations. We'll also be using the true length of hip per metre run, which is here on the sheet, and the answer for that one was 1.527. So we'll also be using that. Another one of the lengths that we'll use for our calculations is this number here, which is the planned length of hip per metre run. We'll also be using that for our following calculations as well. Okay, so we'll move on to the next sheet, and I'll just go on to the next sheet now, and you can see that it's for standard gable and hip roof rafter lengths. Okay, so I'm going to calculate all the members as you see on your sheet there, right down to the second creeper reduction. But it's important to note that if you're using a pattern rafter, you probably won't need to calculate your common rafter length and distance to Birdsmouth, or your crowned end rafter length and distance to Birdsmouth, because those will be marked on your pattern rafter, and that will be shown in another video when we go through setting out of pattern rafters. But we'll be working through these calculations today. So at the top of the sheet, you can see there that it says before calculating the actual length of roof members, it is easiest to first calculate the members run and then multiply the run by the true length per metre run that applies to that member. So if we're talking about common rafters, pattern rafters, crown end rafters, and also creeper rafters, we're talking about the true length of common rafter per metre run multiplied by the actual run of the member itself. Run is the length measured from the wall plate to whatever the member runs into. So for a pattern rafter runs all the way to the centre of the roof. So effectively the run for a pattern rafter is the half span, which is the distance measured from the outside of the top plate to the centre of the roof, plus the eave width, which is measured horizontally, and that is the run for a pattern rafter. The run for a hip or a valley is measured the same way. It's measured square off the frame. It's not measured along the plan length of the member. It's actually, the run is measured the same way. So again, it's measured from the outside of the top plate to whatever that member runs into. So before you start these calculations, you'll need some information from your particular scenario. So for this scenario, the span is going to be 8 metres, and the eave width will be 600 millimetres. Rafter spacings will be also 600 millimetres. Ridge and hip thicknesses will be 20 millimetres, and rafter thicknesses will be 50 millimetres. So you'll be referring to those pieces of information as we go through these calculations. So the first calculation is for the pattern rafter length. The formula for the pattern rafter length is eave width plus half span in brackets times the true length of common rafter per metre run. So the eave width was 600 millimetres. I'll input that as metres, plus the half span. So what we know is that the span for this particular scenario was 8 metres, so the half span will be the 8 metres divided by 2, so the half span is 4 metres. And the TLCR per metre run for this scenario, if we go back to our previous sheet, was 1.155 metres. So inputting that into the calculator, I'll start with my brackets. I'll enter the eave width in metres, so 0.6 plus the half span, which was 4 metres, close bracket. Then I'll multiply it by the TLCR per metre run, which for our scenario was 1.155 and equals. So the pattern rafter length for this scenario was 5 metres 313. So I'll just put a sticky note there for that. So we might be able to refer back to it later. So it's 5 metres 313. There it is there. Before I move on, I'll just clear that. Now we'll do the next calculation, which is pattern rafter distance to Birdsmouth. And we have half span times true length common rafter per metre run. And as we know, the half span for our scenario was 4 metres, so we just enter that into the calculator, 4 metres, and we multiply that by our true length common rafter per metre run, which was 1.155. So the distance to Birdsmouth for the pattern rafter is 4 metres 620. Now this calculator is rounded up to 2 decimal points. For any of these length calculations, as I've indicated before, always give us 3 decimal points because we're talking about metres. So it would look like this would be 4 metres 4.620, 4 metres 620. And there it is there. Next calculation is for the common rafter length. And the formula for common rafter length is eave width plus half span minus half the ridge thickness. And that's in brackets times the true length of common rafter per metre run. So we already know that the eave width is 600 millimetres, the half span is 4 metres, and the ridge thickness is 20. Well, we need the half ridge thickness. So half the ridge thickness is the 20 divided by 2, so the half ridge thickness is 10 millimetres. So inputting that information into the calculator, we start with the brackets, and the eave width in metres is 0.6 metres, so 0.600, plus the half span, which is 4 metres, minus half the ridge thickness, which is 10 millimetres. And we put that in as metres again, so 0.010. Close the brackets. We then multiply that by our true length of common rafter per metre run, which is 1.155 equals, and we get a common rafter length of 5 metres 300, and that 1 would round up to be a 2. So I'll just input that. I'll just put a sticky note there. So the answer for the common rafter length is 5 metres 302. I'll just clear that before I move on to the next calculation. And the next calculation is for the common rafter distance to Birdsmouth. And the formula for that is the half span minus half the ridge thickness times the true length of common rafter per metre run. So the half span minus the half ridge thickness is in brackets. We already know what the half span is, it's 4 metres, and we already know what the ridge thickness is, it's 10 millimetres. So inputting that information, we start with the calculator, start with the brackets. The half span is 4 metres, minus the half ridge thickness, which is 10 millimetres. So putting that in as metres is 0.010. Closing the bracket, and then multiplying it by our true length of common rafter per metre run, which again is 1.155, and hit equals. And our common rafter distance to Birdsmouth is 4 metres 609 mil. The 8 would round up because the 5 rounds the 4 up to a 5, and then that 5 would round the 8 up to a 9. So the answer for the common rafter distance to Birdsmouth is 4 metres 609. So I'll just put that sticky note there. 4 metres 609. So the next calculation is for valley length. So the formula for valley length is eave width plus the half span minus half the ridge thickness, and that's in brackets, times by this time the true length of hip per metre run. So when you're calculating hips or valleys, you'll multiply by the true length of hip per metre run. So we already know what the eave width is, 600 millimetres. We already know what the half span is, which is 4 metres, and we also already know what the half ridge thickness is, which is 10 millimetres. The true length of hip per metre run, we haven't used that yet, but if we refer back to our previous calculations, that's where you'll find it, true length of hip per metre run. And if I have a look at that, our true length of hip per metre run is 1.527. So going back to the valley length calculation, so we know that the true length of hip per metre run is 1.527 now, and we can input that information into the calculator. So again, we start with the brackets. The eave width is 600 millimetres, so 0.600 in metres. We add the half span, and the half span was 4 metres, and we subtract the ridge thickness, so which is 10 millimetres, and in metres that is 0.010. Close the bracket, so our run for the valley length is 4.590, and we multiply that by our true length of hip per metre run, which was 1.527. So the length for our valley is 7 metres and 9, because the 9 would round up the 8 to a 9 with 3 decimal points. So I'll just input that with a sticky note. The length of the valley is 7 metres 9. There it is there. So I'll just clear that before I do the next calculation. The next calculation is valley distance to Birdsmouth. So the calculation is very similar, as you see. This time it's the half span minus half the ridge thickness times by the true length of hip per metre run. So same information as before, except that you're not adding the eave width. So again, we start with the brackets, and the half span is 4 metres. We subtract half the ridge thickness, 0.010. Close our bracket. That gives us the run for the distance to Birdsmouth for the valley, and then we multiply that by our true length of the hip per metre run, which was 1.527. Equals, so the answer for the valley distance to Birdsmouth is 6.093 with 3 decimal points. So I'll just put that sticky note there, 6.093. And I'll just highlight that because that's the calculation that we just did there, valley distance to Birdsmouth, which is 6.093. The next calculation will be for the crown end length, and the calculation involves the eave width, the half span, and half the rafter thickness. And you multiply that by the true length of common rafter per metre run. So the only thing we haven't worked out so far is half the rafter thickness. So as I said before, the rafter thickness was going to be 50 millimetres. So you divide that by 2, so half the rafter thickness is 25 millimetres. So now knowing that, we input the information into the calculator, starting with the brackets. I'll just clear the previous calculation. So if we enter the calculation now, we start with the brackets, the eave width, which is 0.600, plus our half span, which is 4 metres, and we subtract our half thickness of our rafters, which is 25 millimetres. So we input that as metres, so that would be 0.025. Close the bracket, and that's the run for our crown end. We then multiply that by our true length of common rafter per metre run, which is 1.155. It equals, and for our crown end length is 5.284. So I'll just put that in a sticky note for our crown end length. which is 5.284. And there it is there. So the next calculation is the crown end distance to Birdsmouth. And before I start, I'll just clear the previous calculation. And the formula is the half span minus half the rafter thickness in brackets times the tree length of common rafter per metre run. So again, we start with the brackets. The half span was 4 metres. We subtract half rafter thickness, which in metres is 0.025. Close the bracket. Again, times that by 1.155, which is our true length of common rafter per metre run, equals, and our distance to the Birdsmouth for our crown end is 4.591 metres. So we'll just input that there, 4.591. And there it is. The next calculation is for the hip length. So when you look at this calculation for the hip length, it's the eave width plus the half span minus the half rafter thickness. So that's the run for the hip. And what you'll notice is the run for the hip is identical to the run for the crown end. So once you determine the run for the crown end, you can use that same run to determine the length of the hip. The only difference being that instead of multiplying it by the true length of common rafter per metre run for the crown end, if you're determining a hip, you multiply the run by the true length of hip per metre run. So inputting that into the calculator, we start with the brackets, and the eave width is 600 millimetres, which is 0.6 metres, plus the half span, which is again 4 metres, and minus the half the rafter thickness, which is 25 millimetres, which is in metres 0.025. Close the bracket. We then multiply that by our true length of hip per metre run, which was 1.527, and equals, and the length of our hip is 6.986 metres. So I'll just sticky note that there, 6.986. The next calculation is the hip distance to Birdsmouth, and the formula for that is the half span minus the half the rafter thickness in brackets times the true length of hip per metre run. So what you'll notice again is that the run for the hip distance to Birdsmouth is the same as the run for the crown end distance to Birdsmouth. And the difference being that you multiply the run by the true length of the hip per metre run for the hip distance to Birdsmouth instead of the TLCR per metre run. So inputting that into the calculator, starting again with the brackets, the half span was 4 metres, minus the half rafter thickness, which was 25 millimetres, input that as metres, which is 0.025, close the brackets, that's our run, and multiply that by our true length of hip per metre run, which is 1.527, equals, so our hip distance to Birdsmouth is 6.070, because as you can see, the 8 would round the 9 up, which would bring the 69 up to 70. So I'll just put that answer there with a sticky note. So the hip distance to Birdsmouth is 6.070. There it is there. So I'll just scroll down a little bit. The next calculation is for the first creep reduction. It's bracket, rafter spacing plus bracket again, half the hip times 1.414, close bracket, minus half the rafter, which is the half the rafter thickness, close the bracket, and then you would multiply it by the true length of common rafter per metre run. We haven't determined the half thickness of the hip yet, but as I said before, ridges and hips for this scenario were going to be 20 millimetres. So half the hip would be half of 20, so 20 divided by 2, which would give us a half thickness of hip of 10 millimetres. And we multiply that by 1.414 because the line that we're measuring along is at a 45-degree angle to the half hip thickness. So we need to find out what the length of that is by multiplying it by 1.414. That's why that's there. So inputting that into the calculator, we start with a bracket, and the rafter spacing, which this scenario was 600 millimeters, so 0.600, plus, and then another bracket, half the hip, which we said was going to be 10 millimeters, so as meters, that's 0.010, times 1.414 times 1.414, close that bracket, minus half the rafter thickness, which was 25 millimeters, so as meters, that's 0.025, close the bracket, and then times by tree length of common rafter per meter run, which was 1.155, equals. So our first creeper reduction is 681 millimeters. The 4 will be rounded up by the 5, so that 0 becomes a 1. So the first creeper reduction will be 681 millimeters, or 0.681. So I'll just put that there with a sticky note, 0.681. So that's the first creeper reduction. I'll just clear that calculation. And now I'll go on to the second creeper reduction calculation. And for this calculation, it's simply the rafter spacing times your true length of common rafter per meter run. So pretty straightforward. So again, the rafter spacing was 600 millimeters. Putting that into the calculator is 0.600 times by the true length of common rafter per meter run, which was 1.155, and equals. And the second creeper reduction is 693 millimeters, which is 0.693 meters. So putting that there, 0.693. So that's how you carry out those calculations. What I suggest you do is go back and practice those, again making sure you come up with the same answers that I came up with, and again get used to the way your calculator works. And if you're using a pattern rafter, you won't have to calculate the common rafter and crown end rafter lengths. They will be marked on the pattern rafter by allowing the half thicknesses of the ridge and half thicknesses of the rafter on the end of the pattern rafter. So you won't have to calculate those as we've done. If you are using a pattern rafter and you've got multiple spans for your roof, you're going to have to calculate the pattern rafter length for each span and pattern rafter distance to Birdsmouth for each span as well. And all the other spans will be marked on that same pattern rafter. The creeper reductions will suffice for the entire roof, no matter how many different spans you have. But you also have to calculate the hip length, hip distance to Birdsmouth, valley length and valley distance to Birdsmouth for multiple other spans as well.